Hello, geometry class, and welcome to my basement. Yes, we're going to be doing basement lessons from now on. Sorry it took a couple days. I got the whiteboard in on Tuesday, had to quarantine it for 48 hours before we could get it out of the box, but it's all put together, and hopefully you can read this. So this morning, or this afternoon, I'm going to be talking about the unit circle, how to find the circumference, and converting between radians and degrees. So you're going to hear a lot about the unit circle in upcoming lessons and upcoming math classes, but the unit circle, when superimposed on the coordinate plane, is a circle that intersects, has a radius of 1. So therefore it intersects the axes at 1, 0, 0, 1, negative 1, 0, and negative 1, 1. So my first question would be, what would be the circumference of that circle? Well, think about what the circumference formula is. Circumference is equal to pi times diameter. So if the radius is 1, the diameter is 2, that would make the circumference of this circle equal to 2 pi. Well, on the unit circle, we know that a full circle is 360 degrees. Well, those locations on the unit circle is how we determine what radians are. So therefore, a unit circle would be 360 degrees or 2 pi radians. So we could say that 360 degrees is equal to 2 pi radians. So if we wanted to find out, obviously we got 360 and 2, because these two things are equal to each other. So we can say that 180 degrees equals pi radians. So I don't know if that was clear or not, but the unit circle is, if you think about the circumference, is 2 pi radians. So therefore, if you think about that, 2 pi radians, 90 degrees would be pi over 2 radians. And that's the pi over 2 is the location on the unit circle. 180 degrees, of course, is pi radians. 1.5, this location down here would be considered 3 pi over 2. And then this one back here, of course, is either 0 or 2 pi. Just a location on the unit circle. Now converting between degrees and radians, we'll use this right there. And I'll just do it down here. So if I wanted to say, well, how many radians is 30 degrees? I like to write it out, the word degrees, because it's going to, using my, manipulating my those things, my units, I'll be able to find out how many radians this is. So my conversion here is pi radians and 180 degrees. So I'll use that and I'll flip it up and down depending on how I need it. If I have 180 degrees on top and I want this to equal radians, raise that a little bit, then I'm going to multiply so that I have radians on top and degrees on bottom. That way my degrees cancel. Well, radians, that's pi over 180. So therefore, if I were to find out how many radians 30 degrees is, I would have 30 over 180 pi. Well, of course, that reduces to 1/6. So therefore, we can get rid of the 1. 30 degrees is equal to pi over 6 radians. Of course, if I wanted to do that backwards, radians and degrees, let's say that I have 4 pi over 5. 4 pi over 5 radians. No idea how many degrees that is. However, I know this is less than 1. It's more than a half, so it's going to be somewhere in here. So more than 90, less than 180. Let's try and figure that out. So that would be radians. Pi's on top. I want pi to go on bottom. So my pi's will cancel. And then this is going to give me how many degrees? Well, if I think about this, I can reduce this. I can multiply and divide. I know 5 goes into 180 72 times. So that's 1, that's 72. So I'm going to do 4 times 72. I'm not sure if that is right. Hey Siri, what is 180 divided by 5?
It's 36.
36, that's 72. I don't know what I was thinking. Thanks, Isaac, for correcting me on that one. So we got 4 times 36. 4 times 6 is 24. Carry the 2, so that'd be 144 degrees. So from radians to degrees, multiply by 180 over pi. From degrees to radians, multiply by pi over 180. But basically, that's how it is. Make sure you write your units out, and you can go between radians and degrees and radians. I'll come back here in a second and explain to you how to do it with arc lengths and sectors. But for now, good luck on the first comment.